Should be connected to that. That's kind of weird, didn't it? Oh, I didn't connect those speakers. That's okay. Okay. So there's a new theorem that we're going to talk about. It's called triangle inequality. And we're going to do a little demonstration. This is actually a very interesting topic because you never see this ever again in any of your future geometry units or in Algebra 2 or in pre-calculus or in calculus. Yet, this does show up on the SAT exam. So when I usually work with a high school junior for the SAT and we talk about, they don't know the answer to this question because they forget. So it's like one day and we don't talk about it ever again. Maybe because I'm making such a point of it, maybe we'll remember. But here's the deal. The longest side, I'll kind of tell you what's happened. The longest side has to be less than the sum of the two short sides. Otherwise, if the triangle is physically impossible, it'll be impossible to connect the sides. So the longest side's always going to be less than some of the two short sides. Let's look at this little demonstration so you can see for yourself. Okay, let me go and clear this for a moment. So right now, my side lengths are AC is 15. BC is, well, when I connect it, it's going to be 16. And AC is 9. So if I were to move this, yeah, they could link up. So that's a possibility, right? But what if I made BC what if I made that too small? Okay, can I somehow connect these two? Are they ever going to reach? They will not. What's happening here, it's kind of like if you took like 3 different size pencils. One's really long and the other two are really short. That's going to be a problem. So you can notice that the side AC is too long. AC is too long because notice that AC is greater than AB and BC. That's a problem. They'll not connect. So in order for them to connect, what could I do? I could shorten AC. Oh, now they touch. See how AC dropped to 13? Now it's less. So now it's 13. And now it's less than some of the two sides. That has to happen. That's why it's called the triangle inequality theorem. You're dealing with an inequality, and in order for the triangle to be legitimate, the long side has to be less than some of the two. Go ahead. Great question. It would collapse. If you got 4, let's say I made that 14. Then what has to happen is I'd have to bring this down. Then they finally link up. But the problem is you have no triangle still. It's just a line. So very, very important. This longest side has to be less than the sum of the other two sides. Very, very important. Like for example, I could make that too big. Maybe I'd make that like say 19 and make that like, so I still have a problem. They're still not going to touch. So that's an issue. And even if I can't really move A because I didn't really. But see now, I can get them to connect. So that's what's happening. Okay, so I think I kind of made that point clear. So yeah, that's it. Just make sure that the longest side is less than some of the other two sides. So now of these options, of all these trios, which one is not okay? And which one is okay? Is the first one okay? No, because 10's too much. It's too much.
Oh. Okay.
But is 2 okay? Is 3 okay? Is 4 okay? Right. Because 10, for the first one, 10 is greater than 3 plus 5. Here, 8 equals 3 plus 5. So for triangles that cannot be built, what happened? You could say the triangle collapsed, or the side lengths, the two shorter side lengths, that's what I probably want to say. The two actually, no, because that's not necessarily true. Or two of the side lengths don't touch. Yeah, I want to be proper. I says two of the side lengths, two of the sides don't touch. All right. So now, armed with that knowledge, waiting about part B. If two sides are 5 and 12, was the longest I could join them. So how long can I make it? Say that's 5 and that's 12. And I want to connect them. Say I call it X.
17.
X has to be shorter than 17. Okay, so can I say, so if I ask for a whole number, what whole number value would you share? Would you say? What would be the longest whole number value? 16. Now, what if I just said, okay, it could be a decimal? Yeah, but can I say spot? Do I know for certain? Not spot on. I can say 16.9999999 like forever, but it gets awfully close to 17, like infinitely close to 17. But I can't get it spot on to 17. Spot on 17 is a problem because it would collapse. By that same token, you can't have 12 be too big. What if you want to make the green side lower? So what if I reduce this angle? So see how angle 5 and 12 is obtuse? It would have to be actually, right? Because by the way, if we're a right angle, you can use the Pythagorean theorem. I think you'll get 13 for the green side. But if I reduce the angle so that now 12 becomes the biggest side, now go ahead.
If X was like 1, would it still connect? Oh wait, yes. Right.
If X is 1, no, X won't connect. If X is 1. It won't.
But that's
That's why let's look at the next part now. That's the next point we're gonna make. So here we go. So what if I did this? Let's bring this in a little bit. Okay, I didn't do the scale, whatever. It's all good. So you don't want X to be too big. So X has to be larger than what number? To guarantee that these connect. Well, if you do 5, so yeah, but it's gotta be larger than 17. You could do 7.00000000001. But what's the lowest whole number I could use? 8. If you had to go with the whole number. So essentially what's happening is between 8. Oh, you're right. I'm sorry. It's late in the afternoon. I was up early. Yeah, you're correct. Thank you, Reagan. Okay, I'm glad we fixed that. That's been bad. Yes, it can be said. I even said that. Yeah, that's stupid. 7.01. So essentially, right there, your ideas about the restrictions. So the missing side, Connor, go ahead. Correct. That's right. Now 12 be alongside. So the third side of a triangle must be greater than the difference of the two other sides and less than the sum of the other two sides. And that was terrible grammar. Greater. Yeah, that's it. That is the whole essence of this topic here. That's it. The third side triangle must be greater than the difference of those two sides and less than the sum of those two sides. So it is a range that's acceptable. That's acceptable range for the missing side. And that's actually assessed on the SAT or ACT, which I know if you're freshman, you don't have to worry about for at least a couple of years. Sophomores probably next year, but it's a topic people forget. And I'm sure you guys might forget after a couple of weeks. I don't know. Connor, good. Oh yeah, I'm gonna tell. Oh yeah, I'm gonna probably put in the final two. Yeah, because I'm pretty adamant about this topic. I mean, it makes sense physically if you think about it. So anyhow, but it's something that people tend to forget. Even my strongest calculus students, they forget that. So, but maybe that'll change with you guys. All right. So here, determine the minimum maximum limits of each missing side. So let's call this we'll call this X. We'll call this X. And we'll call this X. So it's going to be sandwiched in between two numbers. So what's my range for A? Between what and what? And
32.
okay, what about for B?
1. 29.
Okay, this one's a little funny. Definitely it's got to be less than C plus A. But was I told which one's bigger, C or A? And you got to be careful because if you do C minus A, that could be a negative number. So I'm going to be very proper here. Does anyone know what that symbol means?
Absolute value.
Absolute value.
Mm-hmm.
So to guarantee a positive results, because what if like C were 4 and A were 6, then X is be larger than -2, that would be misleading. So I want to make sure that I get a positive difference. So you want a positive, so it's got to be the positive difference. And actually, that definition I gave earlier on the previous page, let me backtrack a little bit here. Oh, here we go. So please add this to your notes. Greater than the positive difference. I kind of said it. Positive difference. Please make that up with your notes. The third side of triangles is greater than the positive difference of those two sides, or just less than sum. So I just forgot to do that. And let me and then let me go back to the rest of the notes. Here we go. Okay, so we're okay with this? All right, cool. All right, good. We're moving along nicely, so we can do one more set of notes. Then the notes that we started the other day, that'll be homework. We'll start that in a moment. Cool, go ahead. Sure, of course, yeah. Kara, go ahead.
Are we still?
No, we're not behind. No. What I want to do is give you time to work on the project during class. We're going to start the project on Thursday, and we're use next week as well. But there's two phases in it. There's one phase where you have to come up with your design for the first quadrant, and then after there's going to be other stuff you're going to do later on. But next week also we have to start reviewing for our test. So our test is actually going to be in less than 2 weeks. Yes, Monday, not next week, but the following Monday. So we need to start reviewing for that. Anyhow, Pythagorean theorem. You guys should know this, hopefully. And remember Pythagorean theorem? What is it, Reagan? Tell us. You love so much. Good. Perfect. Thank you. You can use X if you want, but yeah, it should be connected to your notes. It's connected. Yes, the same. You just put the ones you just put away. Okay. We're not gonna necessarily do any scissor cutting today, but if I just show you. Yeah, that's all right. We're not gonna do that today. That's okay. Okay. So it says here arrange, blah, blah, blah. I think you get the idea. But let me look here. That might have been a missed opportunity. That might have been good for us to do, actually, the more I think about it. That's okay. Well, I think what they're trying to do here. That's all right. We'll just do the problems. Hold on. First, we're trying to look draw this diagram. Okay, Rory claims that moving the triangles within the outer square won't change the area. What was the total area of the unshaded region? Oh, I guess. Hold on. Well, I'm just trying to understand this. Give me a sec here. I guess they do a verification of that theorem. We'll move on to 2-1-10. Sorry, guys. I should have been a little better prepared for that. Okay, let's look at 2-1-10. William, can you read 2-1-10, please?
This relationship is a powerful tool because once you know the lengths of any two sides of a right triangle, you can find the length of the third side. Use the E tool, Pythagorean theorem, to examine how the square of the hypotenuse always equals the sum of the square of the lengths of the right triangle. Draw a picture to summarize your understanding of this alternative proof.
Yeah, so I think what they're trying to do here is all three of these. So essentially, if you were to take, let me clear this. If you were to take this square and put it in here, and I think we could rotate it. Can I rotate it? Oh no, actually, let's see that. Here we go. Then if you take this, there you go. Oh, okay. Okay, that was good. All right. Will it fit?
Yes.
Yeah, it's kind of like one of these like little shape games that like my 2-year-old plays. So yeah, and there you go. So obviously the area of the big square is c squared, right? C times c. And this square is b squared. And the other squared, of course, is a squared. So yeah, they obviously the two squares add up to the big square. So that makes sense. Okay. So now we see why this works. Now let's move on to the rest of this. Okay, so let's have you guys work on the second page in your table groups. I'll come around and help you guys out. You can be solving for X or doing whatever they tell you to do. Just one problem with coordinate geometry. So you guys in the whole page, all page 2. I'll come around and help you guys out.
Yeah. We can't square root that. Yeah.
Yeah, if you just leave it as a square 41, just leave it alone. Thanks. Thanks. 225, 36, 29. Six. Let me calculate this one here. A part B is gonna be a little tricky. I'm not sure how proficient you guys are with your radicals. It's not. But there's a factor of that is. Yes.
It's
Yeah.
it's 8 and then 9. 9.
Yeah, let me kind of help you guys out because I'm trying to realize.
8 square root 3.
6 root 2 actually.
How do we know?
Okay.
So-
So-
Oh no, because 11 is square. Because it's the
Okay, the first one's really easy. That's just root 41. If you ever run into a square root that's not a perfect square, you leave it alone. So root 41. You can put it as a decimal if you want, but if I ask for exact values, then leave it as a square root. Okay, but
You just like square root the whole like. Yeah.
you can't, no. Because you'd be displaying the order of operations.
It's not accurate.
Is that what you're asking? Or actually,
That's because I just like put a square root of like the whole thing.
oh, sure, you could do that. You just want to be careful. I'm sorry, I was thinking something else. Yeah, we could, yeah. I mean, X would be a square root of the whole thing, sure. Oh, over the whole? Oh, I see what you're saying.
Yeah.
Oh, wait, you're saying this? Oh, I got you, okay.
Not equal that, like you put it right now, yeah.
Oh, I see. And square those individually?
So like,
Cannot.
so you just get rid of it.
You can't. No, because you'd be displaying order of operations.
Oh.
Because what's happening. You're not realizing there's actually a parentheses here. And that has to be taken care of first. Then in a square root, which also you guys haven't realized yet, is actually an exponent. So the P comes for the E. You have to take care of that first. Or if you look at this, the left side alone, you'd have to square these before you add them, right? You wouldn't have 5 and 4 first. You would have to do 5 squared and 4 squared, then add them afterwards. So you gotta respect the order of operations. Very important. Now for the second one, hopefully got y squared with 72. Now, if you let this root 72, I'm okay with that. But ultimately, we're going to talk about radicals and how to simplify radicals. I think in our next class, we'll do that. And I'm sure, hopefully, you guys did this in middle school or in Algebra 1. Identify a factor essentially as a perfect square. So perfect squares are numbers like today, like 9, 16, 25. 4 square, all those things. The largest number of all the factors essentially as a perfect square is 36. 36 is a factor of 72. 36 is a perfect square. So if I were to think about it, that's 36 times 2. And then you can square root those individually. You're allowed to do that. So that's 6 root 2. So you can break it up that way. Because the square root is like an exponent. And so you're allowed to actually decompose that square root in this manner. Do it individually. I collected here on the Maggie.
Oh, may I go to the bathroom?
Oh, sure, go, yeah. But
Fine. Probably not really. So there wouldn't be another like square root thing for like 91 units, but all 34 with like 9, 6.
I meant the whole year of 2025. Yeah, no, of course, yeah, yeah, like in year like 4, 9, 36, sure. There'll be one later this year. No. Actually, later this month, 9/25/25. Yeah, right. So yeah, 9 days will be another special day. Actually, I lied. Yeah, there is actually another one that does. So 9 more days from now. But then after that, I think it'll be another 91 years after. because 2025 is square that's 45, then the next one would be 46 squared, which is 2116. Yes, exactly. Yes. Okay, for B is kind of weird. So if you do Pythagorean theorem, you should get root 189. Because you gotta do 225 minus 36. Now that actually does have a factor as a perfect square. 9's a factor of 189. So if you think about 9, if you do 189 divide by 9, you get 21. So 21 times 9 is 189. So you can do root 9, it's 3 root 21. Now, if you're asked to find the perimeter, this is a little tricky. Let me get rid of this stuff here. It's a little tricky, but if you were to put 3 root 21 over here, 3 root 21 over here, and of course that's 6. The perimeter when you add up all those sides. 6 plus 6 is 12. And because these are radicals, you have to treat them like terms. 3 root 21 plus 3 root 21 is 6 root 20. You can't combine the 12 and 6 root 21 when you add it. You just have to leave it alone. For multiplication, of course, if you multiply 6 with 3 root 21 becomes 18 root 21. You do that also. It's another way that could happen. All right, let's keep on moving. Has anyone tried C yet? Okay, once you guys try C, and the last one, then we'll check in. Without realizing, you're actually using distance formula for part C. Here's A. Here's C. So you gotta find the length. We'll call this B. So you should be able to find the length of AC from that. And for 112, the Garcia family took a day trip from Cowpoke Gulch. Their online directions told them to drive 4 miles north, 6 miles east, 3 miles north, and 1 mile east to Bighorn Flat. Draw a diagram to give the direct distance.
You can draw another one.
That's for 112. Okay, so you got some diagrams to help you out. Hope you guys can figure that out, what to do. Okay.
Yeah. You know, service learning,
Office? Oh, the surge meeting, or I was supposed to go to that. I can't go out today, but I'll find a moment. I'll tell you. Okay, so for C, you guys might remember the distance formula from your Algebra 1 or middle school math class. It's really just Pythagorean theorem. Like this formula looks really daunting, like it's a radical, like all these subscripts and whatnot. Just draw the darn triangle, right? There's a triangle.
Rise over rise.
Yeah, I mean, that's, but that was slope. But, we're just at, we're asking to find the distance between the two. Slope, of course, is, 7/3, sorry, -7/3. But in this case, you know, AB is 3, BC is 7. If I did Pythagorean theorem, I should get √58. So that's the length of AC, so you don't really have to use this as formula, just use Pythagorean theorem the whole time. Here. I put this on a quarter plan, was up 4, 6 east, 3 north, 1 east. Connected, realized, oh, okay, cool. That's 7 and 7. Yeah, because 7 right, 7 up. And if I do Pythagorean theorem, I should get √98. Or 7/2. And why 7/2? Because if you try to find factors, 98 is a perfect square. So 98 is obviously all numbers are divisible by 1, but 98 is not divisible by 4. It's not divisible by 9. It's not divisible by 16. It's not divisible by 25. It's not divisible by 36. It is divisible by 49. 49 times 2 is 98. √49 is 7. That's why you get 7/2. Okay, so it's perfect timing. So the rest of the class, if you're a little tired, I get it. The rest of the class, you could work on homework. Homework is going to be the rest of this packet. So the previous packet that we started in the previous class, correct? The one with the triangles. So you, yeah, 2, 2, 1, correct. So you're just going to work on the rest of this as homework. Just so you know, some of these formulas for area. Area of a triangle is 1/2 times base times height. Yeah, the whole thing. Area of a parallelogram is base times height. Area of a trapezoid is 1/2. So that's essentially homework.
Should we always like fade out the formula first before we
no.
solve?
It's up to you. I don't care.
Okay.
You know,
Okay.
how to do this fall.
It was very cute.
Okay, what is my number?
Yep.
So
Yeah.
Oh, you guys have to do page 2, guys. Sorry, my bad. Sorry, you're starting at page 3. My apologies.
Alright.
Starting at page 3. Yeah, I don't know what's the page. Hold on.
1, 2, 3,
Oh,
4.
yeah, there it is.
1/2 times.
3, page 3.
What left?
14.
Of the two,
277.
of the two,
Oh,
yeah, thank you very much.
yeah. Do base any height by 2.
Correct, yes. Yes, that's why you do.
So it's.
Oh, okay, no worries.
no,
Let's get to another one.
That was 43. Yeah. It's 43.
40.
But then so A equals to. Then this is
There you go.
No.
No, just half of 14 times 3. If it helps, you can, but it doesn't, it's not necessary. You already have the height.
Oh, it's like
And then
Yeah, 6.8.
And then 5. We need the house. It's like for the internal.
No, the week of the test on Tuesday, we don't get to. We have that class. Oh, is it on Monday or Tuesday? Was reading next Tuesday class? We don't get to.
No. What is the
It was 5 and 8 and then 40 half. Like that.
For Mr. Five times.
Yeah.
5 times what?
For number 2, what's the unit?
Inches. The double.
And then the only one is feet, right? Like
Yes,
one-
correct.
So real, and then I'm like, great, I'm like, I didn't have.
Great question.
I thought eight.
6. Only use the side base. So we put 2 just to expand it, just to help find the height. Actually, I don't think that makes any sense. So you want to do half of 6 and 5. What is it?
Is this the triangle?
Doesn't make any sense.
Or is this whole thing? The whole,
Right.
like, oh.
But that doesn't sound like that. So we'll.
Jocelyn?
No, I know, but just the side, we'll do it something. Anyway, I'm sorry.
How do you explain that? Oh, sorry to find the right height.
I just said like the side of the whole triangle, and I said our tells wrong because it's not even at any height. She's just pointing out the side angle.
What?
For number,
Mario's right?
Jocelyn. Jocelyn's right.
Regan,
Oh, yeah.
thank you, Peter. Thank you for sharing that.
Why are the other two wrong?
I
Mario only has the height of a little bit of it.
That's not a good explanation. I said like Raquel is in a good state.
Yeah.
We have this.
You want to be on it again? Yes. Maybe 5. 5 goes with the biggest the left, and then 1 on the left. Maybe 14 times 5. 145. Oh, yeah. Oh, it's a opposite, so it's one, huh?
How do you, oh.
Wait, are you only finding this one?
Yeah, so for this
Wait,
one
you're
here,
finding that one, right? You're not finding the triangle.
so you could do a couple things here.
Triangle on the left. And the base is 6 and the height is 5.
You could say this, if that's 5 and 3, this has to be 6.
What's the?
It's so awesome.
So you find the area of the rectangle, which is going to be 70. And then this is going to be 15. And that's going to be 7.5. So use 70 minus 15.
Wait, what is the formula I missed?
I'll tell you in a moment. So it should be 47.5, but you could also use this B1 plus B2 over 2 times H. So it'll be 19 over 2 times 5, which is 95 over 2, or still 47.5. So you could think of it like that. Parallelogram.
Yeah.
So you could do this.
I forget what part is called.
Do that. So that's going to be
This number. And then subtract it.
yes. So it'll be 6 by 13, which is 78. But that's going to be 12 and 12. So take that away. You should get 54. Or you do the height times
Oh, I'm
the
not doing
base.
that one. I'm doing.
You also get 54.
I'm doing is exactly. So this is the fact that put pounding is, when I put two triangles, that's minusing five. You have to, yeah.
No, okay, next one. Yeah, you want to show you that. Oh, no.
So
her area of her rectangle is 1 So you can make a You guys have it. I don't know. I'm gonna do.
Yeah, just so you know, for a parallelogram again, the area is BH. And for a trapezoid, it's B1 plus B2. 1/2 times H. Just so you know.
No, wait, 8 is 47.5.
B1.
Five by two, 7,000.
Wait, how do you not get to 61, and shows that? Wait, how do you?
Yeah, go ahead, Faith.
I'm gonna be 9 and 5. You're taking square root, wouldn't make it like.
Lost myself.
Because 19 divided by 12.
No, we don't want to do that. We want to find something.
Oh, yeah, oops,
Just pieces.
oops, and then,
And the whole thing, five.
yep, and then you,
Subtract the 2 parcels.
yeah, oops, thank you.
How many methods do we need for each? Okay.
But that's a question asked.
Saying, so like I could just do that.
That's really cool. Yeah, that works. I mean, there's a more explicit formula that takes you directly to the area. And you're trying to discover that.
For both, or do I?
Sure, yeah, sure. Yeah, I mean, I would just, personally, I think as you guys are doing it the first time, try breaking the recognizable shapes. Like try to find big shapes, back to the shapes you do know. Or try to like break the small shapes and add up those shapes. Do that as well. Okay, cool. So we'll start the project on Thursday. Think about your partners, build that Google form. I'll tell you who your partners are in class on Thursday. All right,
I'm gonna request.
cool. All right, enjoy the rest of the afternoon.
Oh, wait, what room is the service meeting at?
Oh, yeah, sorry. Let me stop my recording also.